In C#, variables, based on how they are stored in memory, are categorized into two types: reference types and value types. A value type is a data type that directly holds a value within its own memory. This means that the variable itself contains the actual value. All simple types, such as integral numbers, decimals, characters, and booleans, are value types. Unlike value types, reference types in C# do not store their value directly. Instead, they store a memory location or pointer that points to the actual location where the value is stored. This means that a reference type refers to the data stored elsewhere in memory. In simple terms, a reference type holds a pointer to another memory location that contains the actual data. Examples of reference types include strings, arrays, user-defined classes, and all instances of class objects. Hello everyone, welcome again. To better understand classes and objects, it's important to know how they are stored in memory. Okay, let's illustrate how value types and reference types are stored in memory using an example. Let's start with value type variables. When we declare the variable number 1 and assign 10 to it, the compiler allocates a memory space specifically for number 1 and directly stores the value 10 in that memory space. Now, let's consider another variable named number 2 that is assigned the value of number 1. In this case, the compiler allocates a separate memory space for number 2 and directly stores another value of 10 in that memory space. As a result, we have two separate memory locations, each containing the value 10. If we later change the value of number 1 to 5, the new value 5 will be directly stored in the memory location allocated for number 1. However, the memory location allocated for number 2 will still contain the original value 10. To confirm this, let's dive into VS Code. First, let's declare the number 1 variable, followed by the number 2 variable, and assign the value of number 1 to number 2. Next, let's change the value of number 1 to 5. Finally, let's print the values of these variables. Now, run the application to see the result. As you can see, after changing the value of number 1, the value of number 2 remains unchanged. Alright, now let's illustrate how reference type variables are stored in memory using an example. Suppose we have the team class. Here, we have an object of this class named team1. During the instantiation process, the compiler allocates two memory locations, one for the team1 variable and another for the actual data. The team1 variable holds a pointer to the memory location that contains the actual team1 data object. Next, by declaring team2 and assigning team1 to it, a new memory location is allocated for the team2 variable. The memory location of the team1 object is then passed to this new variable. As a result, both team1 and team2 variables point to the same memory location that holds the actual data. If we modify either of these variables, such as changing the value of jersey color using team2, it will affect the other variable as well, since both team1 and team2 point to the same memory location that holds the object's data. This is how reference type variables store their data in memory, and this is their behavior when we modify them. To confirm this behavior, let's give you an example. Okay, here, let's declare another variable of type team and assign the team1 variable to it. After that, we'll print the jersey color of both team1 and team2 objects. Then, let's change the jersey color of team2 to blue. Next, we'll print the jersey color for both of them again. Now, let's run the application to see the result. As you can see, even though we only changed the jersey color of team2, the jersey color of team1 has also been changed. This happens because both variables hold the memory location of the same data. When we modify this data using either variable, it affects the other variable as well. This is how reference type variables behave, and all objects created through classes are reference types. Okay, done. See you soon with another lecture.